Hey peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the Grade 11 2018 Physical Science paper, and this is question 10 on electrostatics. So it says 2 points P and T are situated 3 millimeters apart in the electric field of positive charge Q as shown below. Okay, 10.1 says draw the electric field pattern around charge Q. So we know that positive charges radiate their electric fields and negative charges have electric fields going into them. So if we have a positive charge here, it's going to radiate outwards, the electric field. So it's very important that when you draw these lines, they don't cross, because field lines can't cross. But also they radiate outwards. It would be the opposite for a negative charge. Okay. Then it says the magnitude of the electric field at point P is 4 times 10 to the 6 newtons per coulomb, and at point T, the magnitude is 2.5 times 10 to the 5 newtons per coulomb. Then it says calculate the ratio of the electric field at point P to the electric field at point T. Okay, so a ratio is just simply a fraction, yeah? So we can do it in the form of EP over ET, and that would kind of translate to having this ratio that they've asked for. Okay, so all we do is 4 times 10 to the 6 on top and 2.5 times 10 to the 5 on the bottom, and that is equal to 16. So then we know that the ratio is 16 EP to 1 ET. So that is saying that the ratio is 16 to 1, basically. So you can write 16 to 1. Great. So then 10.2.2 asks for the distance between charge Q and point P. Okay, so I'm just going to erase some of this for space. Okay. So let me just draw a little diagram. There's our charge Q. Then we've got some distance till point P, and then we've got some distance till point T. We know that this distance is 3 millimeters or 0.003 meters. And if this is Q, let's call this distance R. That's what we're trying to work out. So if we use kind of a simultaneous equation approach, we can work out basically the electrostatic force of P, and then we can work out the same thing for T, and then we can equate the two. Great. So we can start with P. It's just 10.2.2. That is EP is equal to K. Then that is Q over R squared. And that would be the distance from Q to P over there. Okay, so that's R. And then we know that EP is 4 times 10 to the 6. We know K is a constant, and that's 9 times 10 to the 9. And then we don't know what Q is, and we don't know what R is. So if we rearrange that equation, we get 4 times 10 to the 6 times R squared is equal to 9 times 10 to the 9 times Q. So we can call that our equation 1. So if we do the same thing for T, it's the same at first, the charge is the same, but now the R becomes this distance over here. So it becomes R plus 0.003 meters squared. Okay, so if we put down the information we have, so that's 2.5 times 10 to the 5 is equal to 9 times 10 to the 9, which is K. We don't know Q, and we don't know R. Okay, but if we rearrange that equation, we get that's 2.5 times 10 to the 5 times r plus 0.003 all squared is equal to 9 times 10 to the 9 q. And this is your equation 2. So then if we do a simultaneous equation and we say that equation 1 is equal to equation 2, and we cancel out the q's, then we get an equation in terms of r, and that is 4 times 10 to the 6 times r squared is equal to 2.5 times 10 to the 5 times r plus 0.003 all squared. Then you can put that in your calculator and it comes out with r is equal to 0.001 meters, which is also equal to 1 millimeter. So that is the distance between Q and P. Okay, cool. So then 10.2.3 says find the magnitude of charge Q. So we can use the answer that we just got. So I'm going to leave that there, but I'll erase this. So 10.2.3. Okay, and that says, okay, so let's start with the formula. We can use P because we now have that R distance. So we're going to say EP is equal to KQ over R squared. We know what K is. We don't know what Q is. That's what we're working out. And we know what the R is. We've just worked that out to be 1 millimeter. So we know the magnitude of the electric field is 4 times 10 to the 6 for P. We know that K is 9 times 10 to the 9. Q, we don't know. And R squared, that is 0.001 meters squared. Remember that this has to be in meters. Okay, and then if we solve that, we get Q is equal to 4.44 times 10 to the minus 11 coulombs. Okay, and that's it for this question, but before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also be sure to visit our website for more of these epic tutorial videos, and if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. So until next time, stay epic.